both terrible and beautiful, that demands our intellectual and moral seriousness. Whether we call this religion or philosophy, it motivated Einstein's scientific work and shaped his ethical commitments. It remains one expression, perhaps the most intellectually sophisticated expression, of humanity's perennial religious impulse to find meaning in confronting the cosmos. Part 5, The Nature of Time, Block Universe, Arrow of Time, and the Present Moment. Einstein's relativity forced radical reconceptualization of time's nature. The implications extend far beyond physics into philosophy, consciousness studies, and our basic understanding of human existence. If relativity is correct, then much of our intuitive understanding of time is mistaken. The past, present, and future may not be what they seem. Relativity implies what philosophers call the block universe, or eternalism. Imagine all moments of time, past, present, and future, existing simultaneously in a four-dimensional space-time block. Your birth, your current reading of these words, and your eventual death all exist equally, located at different positions in time, just as different locations exist simultaneously in space. Nothing comes into existence or passes out of existence. Everything simply exists at its space-time location. This view contradicts presentism, the common-sense belief that only the present moment exists. According to presentism, the past no longer exists, and the future does not exist yet. Only now is real. But relativity shows that simultaneity is relative to the observer. Different observers disagree about which distant events are happening now. If observers cannot agree on what constitutes the present moment, how can only the present be real? The philosopher Hilary Putnam formalized this argument. Consider two observers moving relative to each other. Events simultaneous for one observer occur at different times for the other. If reality consists only of what exists now, then the two observers inhabit different realities. But this seems absurd. Reality should not depend on one's motion. The only solution is that all moments exist equally, forming the four-dimensional block universe.
A little over a decade ago, Tony Robbins taught Oprah to walk on fire. According to Tony, he didn't do it through motivation.
Einstein himself endorsed this view, though his statements were sometimes ambiguous. When his dear friend Michel Besso died in 1955, Einstein wrote a consoling letter to Besso's family. He said, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. This suggests Einstein accepted the block universe and rejected the special reality of the present moment. The philosophical implications are staggering. If the future already exists, then it seems to be fixed and unchangeable. Everything that will happen is already real at future space-time coordinates. This appears to eliminate human agency and make the future predetermined. Our sense that we can influence future outcomes becomes illusory. Defenders of the block universe respond that this conflates existing with being unchangeable. In the block universe, your choices exist just as much as any other events. Your decision-making is part of the space-time structure. The fact that your choice exists at a particular space-time location does not mean it was determined by earlier events. The block universe is compatible with both determinism and indeterminism. But critics maintain that the block universe still seems to eliminate genuine becoming and change. Change involves something coming into existence, that previously did not exist. If everything exists eternally in the block, nothing truly becomes. We seem to experience time flowing, the present advancing from past toward future. The block universe renders this experience illusory. This raises the hard problem of time's passage. Why do we experience time as flowing if time is actually static like space? Why does consciousness seem to move through the block universe rather than existing simultaneously at all moments? Philosophers offer various answers, none fully satisfying. Some argue that consciousness necessarily experiences the block sequentially because mental states require time to process information. Your brain at one moment accesses memories of earlier brain states, creating the subjective sense of passage. But this does not explain why we experience time flowing in one direction, from past to future, rather than randomly or backward. The arrow of time, the asymmetry between past and future, poses another deep puzzle. Physical laws at the fundamental level are time-symmetric, working equally well forward or backward. If you watch a film of subatomic particles interacting and run it backward, you cannot tell which direction is correct. Both directions obey the laws of physics. Yet our experience shows radical asymmetry. We remember the past, but not the future. We can influence the future, but not the past. Effects follow causes in one temporal direction, not the reverse. Eggs break, but do not spontaneously reassemble. Living organisms age and die, but never age backward to youth. This asymmetry arises from thermodynamics, the physics of heat and energy. The second law of thermodynamics states that entropy, meaning disorder or randomness, always increases in closed systems. Orderly configurations spontaneously evolve toward disorder, but disorder never spontaneously organizes itself. Ice melts into water, but water does not spontaneously freeze without external intervention. The entropy increase defines time's arrow. The past is the direction of lower entropy. The future is the direction of higher entropy. Our memories work forward through time because memory formation requires creating ordered structures in brains, which increases entropy elsewhere, consistent with time's arrow. But this raises a puzzle. Why was entropy so low in the universe's past? The Big Bang began in an extraordinarily ordered, low entropy state. Ever since, entropy has been increasing, and this increase makes time's arrow possible. But why did the universe start with low entropy? This seems to require special initial conditions that appear fine-tuned and unexplained. Einstein's relativity does not solve the entropy problem, though it provides the framework within which the question arises. General relativity describes space-time geometry and gravity, but says nothing about why entropy increases.
If you were born before 1979, may I ask you something? Have you ever felt...
The arrow of time remains one of physics' great unsolved problems. Another temporal puzzle concerns the specious present, the experience now that seems to have duration. The present moment does not feel like a mathematical instant of zero duration. It seems to last perhaps a few seconds. We experience a specious present, a thick now containing immediate past and incipient future. How does this subjective temporality relate to physical time? Neuroscience shows that consciousness requires integration of information across time. Your brain combines sensory inputs arriving at slightly different times, compares them to recent memories, and generates predictions about immediate future. This neural processing creates the experience now, but this explains how we generate temporal experience, not what temporality is in the physical world. The philosopher Adolf Grünbaum argued that the specious present shows that passage is purely psychological. Physical time consists of a linear sequence of instantaneous moments. Passage occurs only in consciousness as the brain processes information sequentially. Time itself does not flow. We flow through time, or more accurately, our conscious states exist at successive time slices and remember earlier states. Others maintain that passage must be objective because change requires time's passage. An object moving from here to there must traverse intermediate locations sequentially. This seems to require objective becoming, not merely subjective experience. Perhaps relativity reveals that time is more spatial than previously thought, but some residual becoming remains necessary for change. These debates connect to quantum mechanics measurement problem. When does the quantum wave function collapse? Does collapse happen at a specific instant? And if so, how do we identify that instant given relativity's denial of absolute simultaneity? Some physicists propose that consciousness causes collapse, which would make time's passage essential to quantum mechanics. Others deny that collapse happens at all, supporting the many worlds interpretation where the block universe contains all quantum branches. Einstein remained largely silent on these philosophical puzzles about consciousness and temporality. He accepted that the present moment is conventional rather than absolute, and he endorsed the block universe view. But he did not deeply engage questions about subjective time experience or the relationship between physics and phenomenology. The physicist Lee Smolin has recently challenged the block universe view, arguing that time is fundamental and real. Smolin claims that physics has been misled by treating time like space. Time is qualitatively different because only present exists, and becoming is real. He proposes that quantum mechanics indeterminism reflects genuine ontological openness of the future. The future does not exist yet because it has not been created yet. Smolin's position revives presentism using quantum mechanics against relativity's eternalism. If quantum outcomes are truly indeterminate until they occur, then the future cannot already exist in the block universe. The block universe picture assumes determinism, or at least that all possibilities exist in some sense. But if the future is genuinely open, only the present exists, and the block universe is wrong. Critics respond that Smolin's argument fails. The block universe is compatible with indeterminism. Future quantum events exist at their space-time locations without being determined by the past. Randomness does not require presentism. Additionally, relativity's evidence for eternalism is overwhelming, while Smolin's presentism struggles to account for relativity's empirical success.
If you live in England and you're between 50 and 80, there's a chance you...
The debate illustrates how Einstein's work generated questions extending far beyond his direct concerns. He transformed time from an obvious intuitive concept into a deep mystery requiring philosophical clarification. Nearly a century later, physicists and philosophers still disagree about what time is and whether our experience of temporal passage corresponds to anything in physical reality. Time's nature also affects questions about personal identity and death. If the block universe is correct, then in a sense you never cease to exist. Your life exists eternally at its space-time location. Death means reaching the temporal endpoint of your world line, the path through space-time that constitutes your life. But your earlier temporal stages continue existing just as permanently as spatial locations continue existing after you leave them. Some find this consoling, suggesting death is less tragic if our lives exist permanently in the space-time block. Others find it cold comfort. What matters emotionally is that we experience consciousness sequentially, and death ends our sequence. Whether our lives exist timelessly elsewhere in the block seems irrelevant to the lived experience of mortality. Einstein's own attitude toward death reflected his block universe view. He wrote about death with equanimity, even serenity, unusual for someone not religiously committed to an afterlife. He described individuals as transient expressions of the larger cosmos, like waves on the ocean. Waves rise and fall, but the ocean persists. Similarly, individuals come and go, but the cosmos endures. This perspective gave Einstein acceptance of mortality without requiring supernatural beliefs. Whether this attitude is psychologically available to most people remains questionable. Einstein combined extraordinary intellectual understanding with unusual emotional detachment. His cosmic perspective on death might work for rare individuals, but not provide general consolation. The contemporary cutting edge concerns quantum gravity, the still undiscovered theory unifying quantum mechanics and general relativity. Various approaches to quantum gravity suggest that time itself might be emergent rather than fundamental. At the most basic level, perhaps there is no time, only timeless quantum states. Time emerges at larger scales through quantum processes we do not yet understand. If time is emergent, many puzzles might dissolve. The question of what time is would be like asking what temperature is. Temperature emerges from molecular motion, but is not fundamental. Similarly, time might emerge from timeless quantum reality. Questions about time's passage and the present moment might reflect our perspectival access to reality rather than reality's fundamental structure. These speculations remain controversial and experimentally untested, but they show how Einstein's relativistic revolution continues generating new questions and theoretical possibilities. Time, which seemed obvious and unproblematic before Einstein, has become one of physics' deepest mysteries. We use time constantly, yet cannot definitively say what it is, whether it passes or whether the present moment has any objective reality. Part 6. The Unification Dream. His quest for a theory of everything.